When 3I/Atlas entered the inner solar system in late 2025, it immediately captured the attention of astronomers and space enthusiasts worldwide. The object, an interstellar visitor unlike any previously observed comet or asteroid, prompted an unprecedented level of observation from both professional and amateur astronomers. Across the globe, telescopes were trained on the incoming object, capturing every measurable detail of its trajectory, brightness, and compositional features. Its appearance was widely reported, and astronomers eagerly shared preliminary data on its unusual behavior and characteristics. Observatories in Europe, Asia, South America, and other regions coordinated efforts to track its path, attempting to understand both its origins and potential implications for Earth. The data collected included high-resolution imaging, spectral analysis, and long-term orbital monitoring, all of which indicated that 3I/Atlas was unlike any known comet in the solar system. The initial reports described an elongated, rapidly rotating body with a complex coma and tail structure, suggesting that its composition and physical properties differed significantly from typical solar system objects. As public fascination grew, so too did a wave of online speculation. Social media platforms, online forums, and specialized astronomy discussion boards became inundated with theories ranging from the scientifically plausible to the wildly speculative. Among the most persistent and controversial claims was the allegation that a highly classified U.S. planetary defense initiative, purportedly called Cassandra, had been monitoring interstellar objects for decades. According to posts circulating on forums and a few unverified articles, Cassandra, an acronym that has never been officially defined, was a sophisticated observational and computational system designed to detect and track potential extraterrestrial threats before they approached the inner solar system. Enthusiasts and conspiracy theorists alike suggested that the limited commentary from NASA following the detection of 3I/Atlas was a sign that certain governments had already anticipated its arrival and were withholding information from the public. They argued that, had the agency truly been surprised, statements emphasizing urgency and transparency would have been issued immediately, rather than carefully measured and scientific updates that seemed almost deliberate in their restraint. Amid the surge of speculation, the story became further complicated by the circulation of two images allegedly linked to the Cassandra system. On November 2, 2025, a Medium article brought renewed attention to forum posts featuring these images, which were labeled as Cassandra/Oracle 6 Argus VS and C/2025 N1 Umbire 3/C. These photographs, though their origins remain unverified, purportedly depicted structured plasma emissions and geometric radiation patterns surrounding 3I/Atlas. One image showed a high-resolution, black-and-white capture of a bright, well-defined core, from which linear and angular emissions radiated in a highly structured manner. The second image presented the opposite visual phenomenon, revealing a green-hued coma with a glowing white-pink center, accompanied by plasma streams forming intricate patterns that seemed almost artificially organized. Amateur astronomers who viewed these images described the formations as unlike any cometary behavior they had ever witnessed, noting that the release of gas and dust appeared unusually structured and directional rather than diffused and irregular, as is common in solar system comets. This fed further speculation that some active control or exotic natural mechanism was influencing the object's emissions, though no empirical evidence could confirm such claims. Independent verification efforts by astronomers worldwide attempted to assess the plausibility of these observations. While the images themselves remained unverifiable, scientists noted that the trajectory of 3I/Atlas exhibited unexpected angular deviations from the path predicted purely by gravitational dynamics. In other words, the object appeared to be influenced by forces beyond the standard interactions expected from the Sun, planets, and other celestial bodies. These anomalies prompted discussions in scientific circles about the potential for non-gravitational forces, such as outgassing or radiation pressure, contributing to the trajectory deviations. The presence of highly structured emissions, if accurate, would suggest that the object might not behave like any naturally occurring body previously studied, raising intriguing questions about its origin and nature. The association of these anomalies with a source referred to as Cassandra added a layer of mystique, blurring the line between fact and speculation in the public imagination. Despite the excitement generated by these reports, experts emphasize caution. Analysis of the historical record revealed that discussions of a Cassandra-like system primarily originated in conceptual frameworks rather than operational programs. For example, a publication dating back to 2005 proposed theoretical strategies for planetary defense against extraterrestrial threats. The paper outlined potential monitoring and tracking systems, describing advanced computational models and observational networks that could theoretically detect and analyze incoming objects long before they reached Earth. Importantly, however, there is no evidence that such systems were ever funded, constructed, or made operational. In the context of 3I/Atlas, this distinction is critical. While it is tempting for the public and amateur researchers to draw connections between the alleged images and decades-long monitoring programs, the scientific consensus remains that these claims are speculative and unverified. The debate surrounding 3I/Atlas also highlighted the differences in public communication strategies between various space agencies. European and Asian agencies were relatively forthcoming with imagery and data, releasing high-resolution photographs, compositional analyses, and trajectory information almost immediately following detection. By contrast, NASA maintained a comparatively limited public commentary, issuing carefully measured updates and emphasizing that observational data was still being verified. This discrepancy fueled online speculation that the agency might have prior knowledge of the object, leading some commentators to suggest that NASA had been aware of the interstellar visitor long before its official detection. However, professional astronomers clarified that operational silence is not necessarily indicative of secrecy. Agencies often withhold detailed statements until data can be confirmed to prevent misinformation and to maintain scientific integrity. Verification protocols, peer review, and cross-observatory comparison all contribute to the deliberate pacing of public disclosures in astronomical research. The social dynamics surrounding 3I/Atlas also provide insight into how the public engages with space phenomena in the digital age. Unlike previous astronomical events, where information was primarily disseminated through news outlets and academic publications, this event unfolded in real time across multiple online platforms. Amateur astronomers documented observations, social media amplified speculation, and forums hosted heated debates about the object's nature and origin. The convergence of verified observational data and unverified, often sensationalized claims created an environment in which misinformation could thrive. Some forum members even produced detailed simulations and theoretical models to support the idea that 3I/Atlas might be artificially guided or under observation by secret defense systems. While these models are intellectually engaging, they remain speculative and are not supported by empirical evidence. Another dimension of the discussion centered on the scientific significance of interstellar objects themselves. While the focus on potential secret programs captured public imagination, astronomers reminded observers that interstellar visitors are inherently valuable for understanding the formation and evolution of planetary systems beyond our own. Objects like 3I/Atlas can reveal the chemical composition, isotopic ratios, and physical processes present in distant star systems. Studies of their trajectories, rotational dynamics, and interaction with solar radiation provide unique insights into fundamental astrophysical processes. The unusual characteristics of 3I/Atlas